It was just going to be a tools demonstration discussion. But I have a new tool I'm going to release instead today, and it's also going to go over this concept of creating an auto brothel. The type of places unsavory people go to get diseases, and that's what we're going to go over. So we'll go over a little bit of hardware in the beginning. So one of the things I recommend is cheap CAN bus stuff, especially when you're getting started. The top one is CANTAC. That's by Eric Evanschlick. I think that's how you say his last name. It's about, I think, $50. Open source hardware, which is cool. Works pretty well. Another one that's kind of equivalent, non-open source, is USB to CAN. Oh, do you need a mic? Is this better? Yeah, I can hear it a little better that way. Okay. We'll have to try and sit. That'd be weird. Yeah, we don't need the chair. So we have the USB to CAN. That's about $60. It comes from Italy, so you use it to wait a little bit for shipping. I like it a lot on Linux, simply because it shows up as a raw CAN. When you start messing with these, one's serial link, one's raw CAN. I prefer raw CAN, but they're about equivalent. One of the things we're going to talk about is scan tools. These will be both dealership and normal ones. This one's one you'd get from like AutoZone or O'Reilly or any of those kind of places. You basically plug these into your car. They tell you why your engine light's on, reporting what's called a DTC, a diagnostic trouble code, and you can clear them. That's pretty much what they do. That would be what a normal person has. And then you have a dealership tool. Now these are a lot more expensive. The last one's probably like $100, where these you might be able to get them as cheap as $1,000. But they go up from there. And so this particular picture is a Tech 2 by GM, I believe. Yeah. And they have a lot more connections because they work on a lot of different cars, a lot more features. They do a lot of stuff that's kind of their own proprietary kind of protocol. So there's a generic protocol to get diagnostic stuff, and there's a non-published one. And most dealerships use the non-published one to look at their cars, to get things like VIN numbers and that kind of stuff, or to work on actuators, like roll a window down or unlock a car door, those kinds of things. These are also can be used for reprogramming some of the ECU, which is your engine control unit's firmware. So they're nice. They're nice tools, I guess, to get your hands on if you can. And also part of the overview for software side, we have Socket CAN. This is my preferred method. It's Linux built into the kernel. You have some tools there. That's the CAN packets up there. So I don't know if you can see them. Oh God, you can't see that at all. All right, don't worry about that. It's really, really simple. So CAN packets have an ID. They don't have a source or destination, just a simple ID. They have up to 8 bytes for their data packet, their payload. And that's pretty much it when it comes to looking at them. So reversing them is not too hard. It's mainly just a matter of seeing them, pulling them out of a noise of a bunch of other packets scrolling by your screen, that kind of stuff. The reason I like Socket CAN is because with Socket CAN, you let you use all your different hardware with the same tools. Kind of treats it like a network interface, So no matter which network card you have, in Linux it'll be ETH0. Same here. This is CAN 0, or it could be SL CAN if it's a serial link. But any tool you write can then work no matter what hardware the person picked or used. So the way this new tool came about is kind of an extension of this other tool I wrote called ICSim. This is open source. It's on GitHub. If you search for Zombie Craig and ICSim, you'll find it. It's basically 2 pieces. You have a instrument cluster at the top, which has your speedometer, turn signals, and a picture for your door unlocks. There's another screen that comes up, and it's your controls. The reason why it looks like a game controller is because it works with game controllers. You can work with PlayStation, Xbox, whatever. The controls are pretty much the same as Grand Theft Auto, and as you drive around with it, it controls your instrument cluster on the top. And it does it, but not by using a programming method such as semaphores or anything like that, but does it by using CAN packets, just like you'd have in a real car. So the window you see on the left, that's all the CAN traffic that's going by. And so what you can do is you can practice looking at CAN traffic, identifying different things like what controls the throttle, what does door unlocks, and then you can send packets just like you would on a real car and see if it actually has an effect. Does it unlock the car doors? Those kinds of things. And there's a lot of background traffic that comes from real car traffic, actually my car. So that's valid. And so it'll really get you used to looking at CAN, doing that kind of stuff. You can change the difficulty levels. So once you do it once, you can play it again, that kind of stuff. One thing I noticed from doing training classes is there's certain tools that work against components, such as engine control units or body control modules. Those don't work with IC-Sim. It's mainly CAN traffic. So I want to make another tool that allowed you to do queries for diagnostic trouble codes and those kinds of things in a virtualized environment. The nice thing about IC-Sim is you don't actually need a car to do it. So I created this thing called UDS server. So also free, GitHub, Zombie Craig. I know you can't read it, but that's where it's at. And so that allows you to run that. You can run other tools like Kah and Caribou against a virtualized system and actually get results. Kah and Caribou is kind of like InMap for cars. It can do like some brute forcing and that kind of stuff. So you can practice with those. But when doing this, I kind of came to this realization that, we could, instead of doing a virtualized simulation environment for training, I can also use this to attack dealership tools. Dealership tools are usually out of scope for any kind of security development. They have all the keys to all the cars, keys to the firmware, all those kinds of things. So anything you really need is an extra piece of hardware. So that's where the ODB gateway comes from. OBD is the normal port you plug into, and I tend to always say, "Oh, dirty bastards, ODB" instead. So I just went ahead and made a tool. So now I'm not wrong when I say ODB. It's just a different tool. And all it really is you have two OBD ports attached to it. What you have to do is, this is kind of the minimum install. You would run the ground wires to each other, the 12-volt power, and then the green one. So the CAN high, CAN low. That's the minimum. You will have to put a 220 ohms or 240 ohm resistor on the CAN lines for it to work. And depending on what car you're trying to mimic, you may want to wire up some of the other ones too. So if you're doing like an American car, they'll typically have more CAN. So that's a high-speed CAN, but they may have a middle speed CAN or low speed CAN. And in those cases, you want to run those too. But sometimes it's K-line or something else. So your thing will vary, but if you keep it to just CAN high, power, and ground, it's fairly universal. So here is one of the things you can do. You can be any vehicle. If you take a scan tool, which is like the, I have one in here. Oh yeah. I might have to exit out and come back in, I think. Yeah, it happens when I do it this way. So that's this scan tool here, one of the ones from Bosch. It does everything, makes all its decisions based on your VIN. So one of the things you can do is you can send in a VIN from another car, whatever car you want to simulate. So in this case, it's showing a 2006 Dodge Charger. And then when you go through, it's going to make assumptions based on that. You can also make up your own VINs. It's one of the command line options. So we'll do it this way. And so this one is, believe it or not, a valid VIN. It says pwned by Open Garages. VINs have a checksum in them on one of the bytes. In this case, it's the 3 in open. So this tool, if it couldn't do proper calculations on your VIN, that Bosch tool will error. It won't go through and make assumptions. This one's fine as far as it's concerned. It will try to process this one, no problem. You can work from anywhere. This picture was taken at a bar. I have it out there for my laptop. Had a scan tool, doing a bunch of testing. It allows for fuzzing. So not only can you spoof things, you can also send a bunch of fuzzing packets. I think we have some examples of those as well. You can do it for I/O controls. So when I mentioned when you take a dealership tool like controlling door unlocks and that kind of stuff, if you look at the debug log, which is on the left side, I know you can't read it, but it'll basically put in English what's kind of going on. So when you're plugged in this way, you have a dealership tool like an MDI here or the Tech 2, and you go in, you say, all right, unlock the car door. It'll show you on the left in English. It'll say, okay, we're responding to tester present. We've gotten a request for sending data. And then you'll see the highlighted section there, which is saying that there's an unhandled device control from GM, and that's the other highlighted packet. So it's the packets that begin with AE are those I/O controls. And so what you'll know, the reason why it says unhandled is because there's nothing to do from a simulation perspective. And I'm not going to simulate a door unlocking with this because it's just software. I only basically simulate output, not input. So that's why you see it say unhandled, but you would know right away when you hit door unlock, that's the packet you can send to unlock that car door. You don't need the car there to do it, and so if you're The nice thing is, as opposed to getting a rental of a target car and then figuring things out, you can just tell this the car you're interested in. And then as you press the buttons, here's what it would be for those cars. Which saves you a lot of time, so you're not looking through all that CAN traffic to figure it out. Here's another example with the fuzzer. So DTCs for trouble codes. Normally you can get like probably worse 255 trouble codes in a car, although no car really would have something like that. This is where your engine light comes on. This case, what I had done, GM has a different way of sending packet data, so you can spoof a much higher number. So the EBCM module there had like 1,398 trouble codes. Body control module 676. I mean, it's all fake stuff, but like what's happening here is you then have it try and go and display these things. Well, let me see all 1,000 of those and see how the devices handle that. Of course, the goal is to get it to crash. And when you get these to crash, you can then work on getting further exploits to it. Because again, they have the keys to all the other ones. Dealerships are relatively squishy. You know, they have very low security. They don't usually even have an internal IT department. These tools, like I said, are trusted. They're tools that, you know, aren't any kind of like security review kind of stuff. So you can make a malicious car that drives into a dealership, and it's there to attack the dealership. It can, as you plug in the diagnostic tool to see why your engine light is on, it can take over that tool. And then once you have on that tool, you can get onto any other car that comes in, hence the auto brothel. And so, and now we see what this is about. So, you know, I like that picture. So yeah, that would be the case. I mean, I'm not saying you should go and do this, but you, as a security auditor, you should definitely test. When you start adding pen testing tool or these tools for doing pen testing to automotive type stuff. I work for automotive a lot, so it's kind of getting another big area that just hasn't been looked at. There's a lot of interesting stuff there. The UDS tool, just like I said, we got pushed this morning. So there'll be some things, certain tools it doesn't work terribly well with. There's a lot of involvement with getting a little more generic, making the fuzzer better, that kind of stuff. So I'm really looking forward to any contributions too. So if you're working on it, you have problems, you think it could do something better, let me know. Still in the very early stages. I was hoping to take questions. Let's see, we're doing on time. Oh, cool, we can. So any questions about this tool or car hacking tools in general that I didn't cover because I didn't give you the original talk would be okay. You have a question? Yeah. Oh, you're talking about the security access token? Okay, so the password piece that I was kind of referring to that has the keys to the other car are these security access tokens. So typically when you're going to modify firmware, like say change your VIN number, which you can do, you basically just need to do this challenge response. You make a request, it's 2 to 4 bytes usually come back, and you have to give it an equivalent, 2 or 4 bytes that's valid for like a rolling key typically or something of that nature. And so on the dealership tool side or the password tool side, it will go through and calculate what the number should be. It passes it back to the ECU, and the ECU says, all right, cool, now I'm willing to take changes. So with this tool, what you could do if you wanted to is you could spoof the request, so the initial seed part. So to try and get your dealership tool to give you a bunch of valid keys, assuming you have it. A lot of times those password tools don't have a kind of like license. So maybe you only get to push like maybe 10 keys or something like that before you have to pay again. So it may not be that great for you. If you have a tool that can do unlimited unlock still, yeah, you could run it through to kind of get the entropy out of it to determine, well, how hard is it just to guess these tools, these keys. You can use it for that. What I would recommend though for breaking those, there's a couple ways to do it. But for a tool perspective, carrying Caribou is has kind of like Nmap like things, but it also can be used as a framework. I have a module I haven't released, but you can make one too, that does the same kind of thing. For one of the vehicles, it requests the key, the seed, and then I just start brute forcing it. And what will happen is it'll eventually lock you out. It'll say after like 3, it'll be like, oh, too many tries is what your error code is. And so then you send a packet that tells the ECU to reboot. like, oh, you should reboot. And then when it does that, you can do it again. So that just the tool does that. It waits for an error and goes, you should reboot. And then we continue where we left off. And it's not too hard to write. I think it's around 200 lines. That's one way to get that key. Another one, yeah, we got time. So another thing you can do is when you see, like, let me go to that one slide. So here you can see where it does like, oh, I sent a door unlock, and here's the packet that unlocks the car doors. There are other things when you say like, oh, get information like the VIN or things like that. The way dealership tools work, they don't do the standard mode 9 to get a VIN, which is the generic UDS. Is how the other scan tool from Bosch would work. They request data based on a memory address off the ECU or body control module. Those memory addresses, like for your VIN, would be the same place you'd go to change it. So when you make a request to go read it, you can then change that packet to go write it as well. So you can also kind of brute force that memory space to see what else is in there. One thing to look for these keys is you can make a request for the seed, scan the memory space to see if you can see that seed show up in memory. If you do, a lot of times these embedded systems will also pre-generate the response it's supposed to be. And it's usually stored right next to the seed. So you can then make a request, and once you know the memory region, pull off the memory, check the bytes next to it, and then send that as your answer. And it's usually within the right amount of time to do it, and it can be pretty smooth way of unlocking that without having to deal with any of the guessing of the keys or anything of that nature. Not no problem. Other questions? Yeah.
Can you like dump the firmware like off of like an ECU or something like these tools?
The question was, can you dump the firmware? Not with UDS, because you're the component in this case. You can make it would see a request to dump firmware, and you could give it fake firmware. But I think a lot of the dealership tools don't download the firmware and modify and upload them. The way they do is they write the parameters, little spots in the memory. You'd want to go out the other way. You'd want to use like Hare and Caribou or something like that, some other tool to download the firmware. But you absolutely can download ECU firmware and upload new ones. Yeah. Yeah, and entertainment systems. The question is, do entertainment systems reside on CAN bus? And they do, most likely if they come from your dealership. If you bought it at third party, they usually don't. They're not always CAN either. For instance, I have 2009 Honda, and that was on K-line. So it's a different type of bus. They are usually connected to your car. And getting into them isn't always through CAN. You know, sometimes you can spoof things to the infotainment, that kind of stuff. You'll get into your infotainment if you want to hack into that one. You're going to do it differently. You're going to do it through, you know, usually like an update software, that kind of stuff. So like if it has a way of uploading DLLs or new firmware versions, that's a good place to start. You can also take the radio unit out and look for like JTAG and serial lines into it and that kind of stuff. Some of them have Ethernet now, the newer vehicles, and you would just treat that like you would a desktop unit. Yep. The question is there any code signing for like the embedded systems? No, there's no code signing for embedded systems for most things. I mean, some of the newer stuff, there's planning for doing a lot of that. I mean, the PKI infrastructure for doing over-the-air updates, if they have them, it's let's just say it'd be nice to have the PKI infrastructure for it. There is a less than handful of people that I know that are doing a PKI for their updates, and when they do it, there could be an issue as well, like while the infotainment unit itself may check the key information, it may not check if it's pushing out to other devices. So if you have another embedded system, the embedded system itself doesn't check the PKI, doesn't have an understanding of it. So a shortcut that's used sometimes is the beefier component, the infotainment center, does all the checking, and then it's like, oh, everything looks good, and then passes it, usually using just a standard kind of password kind of thing. So you can circumvent the whole PKI if you want by just jumping on the bus and acting like you're an infotainment center, saying, oh, everything was cool, it's totally fine, take this firmware. And I didn't mention this, but if you guys want to participate in just hacking in general, it's a short talk. Feel free to jump on opengarages.org. There's a mailing list there, or you can shoot me an email directly at Craig at, I think at Thea Labs. I have my thing in here. I don't, but it's you can hit Open Garages or go to Craig at thealabs.com. The Open Garages website also has the Car Hackers Handbook for free if you want to download that and look at things. Yeah, I think that should be about it. Oh, you have another question? Yeah. Oh, you want the GitHub URL? Yeah.